Hello, everyone. Welcome to IstioCon Day 1. My talk is called Identity Theft is Not a Joke, Jim, How Istio Ambient Mesh Safeguards Our Pod Identities. My name is Marino Wijay. I am a platform/developer advocate at Solo. This company focuses in on application networking and covers the breadth of service mesh, CNI, and proxy networking for a very unique API experience for a lot of different kinds of workloads. So I've spent a lot of time in the network engineering world, and so you start to see things like ambient mesh show up, and you're like, oh wow, this looks a lot like what we used to do in the networking world. And so, I've come full circle in my career. I spent time at VMware where I first learned about Istio through their service mesh offering, and then eventually joined Solo. So you can find me on the bird/X app if you want, and check out some of my other resources as well. So let's get started. You have the situation of identity theft in a lot of different environments. So for example, you might have lost your wallet and someone else picks up your wallet and basically assumes your identity and makes purchases and racks up your credit card bills, and then now you have to go deal with that with your bank and a whole bunch of other issues. But here's the thing though, like, how do you prevent something like that? There are systems in place to help with that level of prevention. But there's also the other approach of, okay, what do we do when we discover that there are vulnerable workloads that exist in our environment and have effectively just compromised parts of our different environments and different applications, causing a variety of different potential issues. So before we even dig into identity theft and how service mesh or ambient mesh helps with that, let's think back to the OSI model for a quick second. And I always like to start with this and use this as a jump off point, primarily because we have to understand where we can implement levels or layers of security. So we could start with the Kubernetes layer or the physical layer, where we like to provision our workloads and we can drive a lot of automation for how our workloads look. But when it comes to policy around networking, we can start to look at policy resources in our CNIs, for example, or our container networking interfaces. But here's the interesting thing though. CNI technology, or when we even look at regular networking technology, we think about packets and IP addresses. And when we think about those are normally static resources. In the world of containers and cloud native, that's not normally the case. And so when we implement policy at that network layer or that transport layer, it can only do so much for us, especially if an identity might be compromised in some shape or form. So for example, you might have a couple of pods that have consumed IPs in your cluster, and the only identity that they have at the moment is their pod IP, for example. And if for whatever reason one of those pods disappears and that IP gets released back into the pool, if something comes up and takes that pod IP before the system can recognize that, hey, we shouldn't have issued that IP out to that new pod, that new pod could be a malicious one as well. So we have to think along the lines of our network layer can only do so much by preventing any sort of impersonation level of attacks. So let's look at that higher level or that higher layer, the layer 7 or application layer, because when you think of the application layer, there's a lot more rich data that we can be able to make policy decisions on. So if we're able to discern what's in that payload based off of that layer 7 information, we can make a decision to say, hey, you're not allowed because you're not even authorized or authenticated to be able to access this particular resource. So in this situation where we have these two services trying to communicate with each other, we assume that everything is in place, a foundational security capability that's in place to make sure that service A is a legitimate service, and then service B also is legitimate in its own right. But here's the thing, service A wants to be able to do something to service B. It wants to be able to extrapolate some data, or it might want to be able to make some changes to service B. Is it allowed to do that is what we need to consider here. And along those considerations, we also have to think maybe we shouldn't be just simply allowing our resources to work together and communicate freely. I mean, that free lateral movement inside of your cluster is what starts the brewing of a potential malicious attack. So let's look at it from a different angle. So let's just assume you had an impersonator that made its way into your cluster. What can it do? There's a lot of different things it can do. So for example, if it's in your cluster and it's able to communicate with other workloads, we might have a situation of data exfiltration of personally identifiable information, some intellectual property, or other sensitive information that might be critical to your organization or the environments that you run. Another consideration is if something makes it into your cluster and is able to have free reign. I mean, it has the ability to even launch a denial of service attack and make other services unavailable for both the inside as well as the outside world. So when you consider something like that, you want to make sure that services that land in your cluster have some sort of identity to be able to, one, be authenticated, and then two, based off of that identity, decide what we can do, what that service is allowed to do. And then, for example, we also don't want a situation of a meddler in the middle that can mirror your requests or determine the data that lives in your payloads. That's something we want to avoid altogether. So let's review some tenets of a modern secure network. So the first assumption really comes down to making sure that we always assume that the environment that we operate isn't secure. It's a hostile environment. There could be a lot of malicious things hiding somewhere, inside of your cluster without you really knowing. And then eventually, after a certain time period, maybe after 6 months, it actually decides to do something, or maybe looks to see when CPU load might be lowest across the cluster, and then launches an attack at that point. I also want to presume that your environment has already been breached, even though it might not have been. Let's just assume that it has. What are you going to do at that point? You'd want to be able to start implementing policies. I'm not talking about network policies, but policies or procedures which allow you to enact things like network policy or authorization policy or an authentication policy. You also want to take on the mindset of never trusting any single resource and always verifying before any resource tries to do anything. And this really falls down with the idea of deploying a deny all policy somewhere. You could start with a denial policy from a network standpoint, which basically locks down your lateral movement or your east-west movement, or even north-south for that matter. But then you take it another level and then you prevent another kind of denial through authorization. So nothing is able to perform action across anything else regardless, until you start incrementally adding policy to enable what can talk to what. And then you also want to make sure that you scrutinize everything. You can't just simply assume that a workload that you've decided to pick and package and deploy to your workload cluster is a secure workload or a non-vulnerable workload. You want to make sure that just because you pull it down, you actually have the controls in place that if it decides to misbehave, you know how to respond to it accordingly. And then you also want to be able to deploy some sort of analytics to be able to baseline and then capture what's going on in your environment when something goes wrong. So that brings us to ambient mesh and how ambient mesh helps with that prevention of imposter or identity impersonation. So ambient mesh is, we already know what it is. And for those that aren't aware of what it is, it's a sidecarless model of service mesh, or the Istio Service Mesh. So Istio Ambient Mesh is something, again, launched a year ago or just over a year ago, which actually provides you the same capabilities of the service mesh, but at a lighter footprint with simpler operational capabilities, as well as simpler onboarding. There's a whole plethora of benefits that ambient mesh brings about. But the idea here is that, okay, if you're really thinking about identity here, how does ambient mesh truly help with that? So with ambient mesh, the sidecar directly at the workload level is dropped. It's no longer there, especially when we decide we don't want to deploy the sidecar. To be clear, that doesn't mean that you cannot deploy a sidecar resource. You can easily deploy sidecar resources along non-sidecar resources as well. and all can be in the mesh pretty well. So what this truly means is that you actually will have to sit down and think through an additional design consideration around what workloads best respond to having a sidecar, whereas the workloads that benefit from not having one. Now, when it comes to security, this is where it gets slightly interesting, or a little bit more interesting. So with the regular sidecar, you had all of these capabilities built into the Envoy proxy that was deployed as a sidecar resource in your pod. So it'll cover a variety of layer 4 capabilities around connection handling, providing TCP, UDP connections, ensuring mTLS, and then at the layer 7 level, making sure that we can honor requests, return the necessary responses, mirror our traffic, circuit break, and traffic engineer in a variety of ways. Now, in order to accommodate the style of what Ambient Mesh does, and to ensure that we reduce the overall footprint of that sidecar resource, but still have access to it, the sidecar was broken down into two components: the waypoint proxy and the Ztunnel. And the waypoint proxy is something that handles all of the layer 7 capabilities of what the sidecar would do, while Ztunnel would focus in on all the layer 4 stuff of what the sidecar would take care of. Now, with the Ztunnel being deployed, it does a number of things to ensure that we still preserve the mutual TLS capability between workloads. Now, mTLS, we all don't really need a lesson on it, do we? No, I don't think so. By the way, I actually thought that I had 45 minutes for this talk. I'm not sure why. Maybe I looked at my calendar invite and thought, oh yeah, 45 minutes, now I can sneak in a demo. I don't have time for a demo, unfortunately, but that's okay, because let's take a look at what's going on with mTLS. We have, in regular TLS, we have one-way authorization, or one-way authentication, I should say. And with that one-way authentication, we're just verifying that the server is legitimate, that we're accessing a secured set of resources. With mTLS, it's a two-way authentication where the server has to authenticate the client, while the client also authenticates the server to ensure that both ends are legitimate resources. And once that has taken place, your traffic in motion is encrypted, your payloads are encrypted. Now that's important because when you think about traffic going across the public space, plain text, obviously we don't want it to be replayed in any way and then captured by a meddler in the middle to be able to take that information and maybe compromise some of our existing systems. So mTLS and the associated authentication behind it is how Istio works and how Istio Ambient Mesh works going forward. So let's just take a brief deep dive into that authentication. So I'm Service A, and I am looking for a spiffy verifiable ID. Can you give that to me? So your system is going to decide, hey, sure, I have to sit there and think about this, and I need to go back and attest you because we're talking about spiffy here. We want to do some workload attestation. So ring, ring, ring. Hi, I am verifying Service A is legit. Is it legit on the host that it's telling me it's running on? And if that host verifies that, great, we're all good to go. Service A is free to communicate with Service B because we verified Service A. The same process will happen for Service B, only because it needs to happen for that mutual TLS to occur. Now, we have identity figured out. How does this translate to Ztunnel? So Ztunnel does it very similarly to how sidecars do it. By the way, the previous process was specific to sidecars, and that same approach applies here to Ztunnel. Now, in the case of Ztunnel, right, we have an application that will need to talk to application B. App A talks to App B. Now, when that occurs, Ztunnel is going to be notified of that communication stream, and it's going to go out and form an HBone tunnel directly to the destination Ztunnel where the workload exists. But that tunnel itself is an mTLS-based tunnel, and the identities are actually derived for App A and App B on both ends of those Ztunnels, meaning Ztunnel for App A has its identity, and then the Ztunnel for App B has that identity as well. So how does Ztunnel actually capture that identity? So If I'm a Ztunnel on a particular node and I might be representing a workload, I'm going to speak to IstioD and have it attest and create a certificate that's going to represent A. And IstioD is going to go ahead and verify that the Ztunnel is actually allowed to represent A or represent the identity of workload A. Now, as long as this is all good, IstioD will say, yep, you're good to go, and we'll issue the certificate directly to Ztunnel. So now, while that process is repeated for the destination side, we can ensure that the identity is preserved for workload A, and so that identity is fed into the actual Ztunnel itself. And so we know that Ztunnel is basically app A. But this isn't just specific to just one workload. We might have a number of different workloads that need to be communicating across to other workloads and other nodes in the cluster or other environments. And so Ztunnel will be a multi-service, basically sidecar resource, but not a sidecar, obviously. But it would basically provide all of that mTLS capability for all these different workloads on both ends as well. Now, this is actually pretty powerful because you might think, hold on a second, are we talking about a single Ztunnel on a single node in a cluster across multiple clusters? You know, what happens here when we have scale issues? So I'm not going to directly go into the details of this, but you can scale Ztunnel. And in fact, John Howard wrote a blog post around Ztunnel not being a node level proxy. Go read that, go take a look at it. I wish I added it in here, but it's a great reference to really understand the purpose of what Ztunnel is doing and where layer 7 capabilities come into the mix. So we validated the identity of something. We know that things work in terms of, you know, we have authenticated resources and we trust everyone at this point. The next step is really what something is allowed to do, whether a service is allowed to make a call to another service or not based off of that identity. And so the concept of authorization re-enters the chat. With the concept of authorization here, there are two mechanisms in which we can think about authorization. Let's think about layer 4 authorization, because that's what Ztunnel can offer us. It's very much like network policy from my point of view, where you've applied a policy that says workload A can't really make delete calls against workload B. But this is happening at a TCP level. This is not happening at layer 7. So while app A is trying to make that call against app B, and we have a policy that says this isn't allowed, well, the request will get rejected altogether. But realize this is not the same as how this would be handled at layer 7. This is more like, okay, a similar approach to what a firewall will do, where it would look at the traffic, analyze a policy, whether it's allowed or denied, and if it's denied, it basically blocks the traffic. Now, this might work for a lot of situations where you have workloads that really don't benefit from having layer 7 capabilities. But in the situation where you do require those layer 7 capabilities and you want to be able to block based off of an HTTP GET operation, well, this is where the waypoint proxy will come in. So the waypoint proxy is going to be effective in that it'll actually come back in, and once you have it deployed, it'll analyze the layer 7 policy for the workload destination. So you have app A trying to make an HTTP GET or delete against app B. App A can make the GET call, but it cannot make a delete call against app B per that policy. The waypoint has to be the one that enforces that. Without the waypoint, you can't basically be as granular as a GET and a delete operation here. So not only that, like the waypoint provides much more functionality than just a layer 7 policy or an auth policy at this point. Sorry, auth Z policy. It's doing a lot of the traffic engineering at layer 7 based off of that layer 7 header information or intelligence that exists there. So we can't just say, okay, well, I can do everything with Ztunnels. I mean, sure, there are a lot of ways you can get around with Ztunnel. There are a lot of things you can accomplish with the Ztunnel resource, but for that rich level of data, for that rich intelligence, for being able to do circuit breaking, for being able to mirror our traffic, that's where the waypoint's going to come into play here. So having said that, right, I will come back and summarize, but I just wanted to show you a little bit of a clip I don't know how many of you are familiar with The Office, but I always like a lot of their cold openings. They're really funny, very to the point, and very specific. So I'll play this little clip for you, and then I'll come back and I'll summarize the presentation.
It's kind of blurry. That's better. Question: what kind of bear is best?
That's a ridiculous question.
False. Black bear.
Well, that's debatable. There are basically two schools of thought.
Fact: bears eat beets.
Oh.
Bears beets Battlestar Galactica.
Bears do not. What is going on? What are you doing?
Last week, I was in a drugstore and I saw these glasses, $4. And it only cost me $7 to recreate the rest of the ensemble, and that's a grand total of $11.
You know what? Imitation is the most sincere form of flattery, so I thank you. Identity theft is not a joke, Jim. Millions of families suffer every year. Michael! Oh, that's funny. Michael!
Apparently I'm muted. I didn't realize that I was muted all this time, which is a good thing. Thank you so much for pointing that out, because it takes a few seconds for all of the chat messages to come in. So that's okay. I was just saying that I love The Office. I probably will watch it again for like the 13th or 14th time. But it should give you an idea of, this idea of identity theft. When you think about it, everyone in your office that you work with, whether it's remote or in person, they all know you, right? They can all verify your identity, and they trust who you are, and will be willing to work with you. But you have a situation like this where you have someone who pretends to be someone else in the office, and now you have a situation, right? You have impersonation going on, and there could be a lot of different things that go wrong there. Anyways, the Office was excellent inspiration for this talk. It just made me think maybe this is great to talk about overall identities and how that ties to ambient mesh. All right, so just to come back and summarize, so we have to think about identity theft being one of those critical issues. I mean, we can't overlook it. We can't just simply deploy workloads and assume all things will be good. We have to assume a hostile environment. We have to assume that there will be breaches, and we possibly have been breached. We always want to make sure we don't trust every single resource that we throw into our cluster, and we always want to verify those resources as well. Any kind of workload, we want to make sure that we scrutinize deeply and explicitly, so that we implement a model where everything, every object, every resource has a policy against it, run against it, and enforced against it. And we also want to consider the analytics piece of it. So with analytics, we're able to see what's going on, and we can adjust our strategy. So ambient mesh is a sidecar-less mode of Istio, as we already know. Ztunnel provides the mTLS capabilities and assumes the identities of workloads. Ztunnel also provides the layer 4 authorization policies, which gives us more of a firewall-like filtering capability. The waypoint is where we start to get some of those layer 7 authorization and traffic engineering capabilities if we decide we want to deploy a waypoint. So, in a nutshell, ambient mesh still does the job. Nothing different than what regular Istio would have done. If you want to know more, if you want to get your hands dirty, if you want to play a little bit with ambient mesh or some of the other cloud native technologies, head over to Solo Academy and you'll have access to a full environment to try out whatever you want. Maybe you can come up with your own little identity theft lab. All right. Well, thank you very, very much, everyone. I hope you enjoy the rest of IstioCon. I hope to see you elsewhere. Take care, everyone.